Hi guys, welcome back to .NET Go. Our today's topic is what is garbage collector. What is a garbage collector or a garbage collection or a automatic memory allocation, right? So garbage collection is one of the core component of CLR in .NET framework. Now, if you guys don't know what is a CLR in .NET framework or what is a common language runtime in .NET framework, so I strongly recommend it you that please go and watch my previous video first. Okay, so in that video you will find out that what is a CLR and what are all the things going on inside the CLR. So before continuing with this session, I strongly recommend it to you guys that please go and watch that video first. So garbage collection is one of the core component of CLR in .NET framework. Garbage collection, also known as garbage collector and automatic memory allocation. So if some people ask you that what is a garbage collection in .NET framework, or some people ask you what is a garbage collector in .NET framework, or what is a automatic memory allocation in .NET framework, so don't get confused. Basically these three things, these three names reference towards to the same topic. Okay, these three names are basically referencing to a same topic. Okay, and the third point is in .NET framework, a developer don't need to write a separate code for memory management. The CLR only handle the memory allocation by itself. This concept is called as garbage collection or automatic memory allocation. So if you are a developer and you are working in a .NET framework, right? So as a developer you don't need to write a separate code for for doing a memory management, right? So your CLR only will do all the things behalf of you, okay, for your program, to run your program regardlessly in the .NET framework, right? So this concept, this automatic memory management concept, which is handled by your CLR, that thing only called as a garbage collection. And if needed, a developer can handle the garbage collection from coding level as well. The GC class controls the garbage collector of the system. Okay. For example, GC dot get generation method, GC dot get total memory method, GC dot collect method, or there are many more methods also. So what happen is, so if you are a developer in any .NET framework and you are working with the managed code, so it is not necessary, it is not necessary to write a separate code for memory management. So those things are actually automatically handled by your CLR in the backend when you will run your program in any .NET framework. But sometime what happen is, based on the scenario, as a developer you have to write some code to manage your memory, memory allocation. You can write some code also for doing that. So those options are available. It is not necessary to write down a code, but yeah, if you want, then you can write. So how you will write that code? So for that, in .NET framework, if you work with C# and if you are working in Visual Studio, you will find one namespace called system, and inside that namespace, you will find a static class called gc. So inside that static class, you will find n numbers of methods, like I have given some example of it, like get generation and get total memory or collect, or there are many more. So all those methods you can use in your programming. Okay, so it is always use the heap memory. Okay, so remember one thing, a garbage collection always happened on a heap memory. So your CLR take a chunk of a memory which we will address here by a name called heap memory, and your CLR handle all those garbage collection in the heap memory. Even though if you write it down a code manually also for for any garbage collection, that thing also happened on that particular heap memory only. Okay. Okay, phases. So before starting with this particular slide, okay, first let me tell you about the heap generation. Okay, there is something called a heap generation in garbage collection. Okay, first understand this thing first. Okay, so if you understand this topic, that what is a heap generation in garbage collection, then you will easily understand that what are all the phases garbage collection have. That is why I first started with the heap generation thing. Okay, so first of all, what is happening in garbage collection is that uh, the CLR will allocated one heap memory with for dedicatedly a heap memory dedicatedly for your particular program. Okay, when you want to run your program on any .NET framework, the CLR, first of all, what it will do is the CLR allocated a heap memory for your program. Okay, and what happen is the CLR will divide that particular heap memory in three generation. Okay, here we will call it as a generation, but you can assume it that it will divide it in three parts. Okay, your one big heap memory will divide it into three parts. Okay, now these three parts we will call it as a generation 0, generation 1 and generation 2. So here you can find a diagram also. So generation 0, generation 1 and generation 2. So in total you can assume that there will be a one heap memory in. So from that one heap memory, your CLR will divide that heap memory in three parts. So the first part we call it as a generation 0, the second part we call it as a generation 1, and the third part we call it as a generation 2. Okay, now why your CLR even divided one big heap memory into three parts, right? So these things we need to understand very carefully. So I recommended you to watch this particular part of this video very carefully. Okay, very carefully. So what happened is your CLR, okay, suppose this is the total heap memory a CLR has dedicated to your program to run, right? So inside this heap memory only the total garbage collection will be happened, okay, throughout the life cycle of your application. Okay. Now what the CLR doing is, from that big heap memory it will divide it into three parts, right? So suppose uh, it is first thing, it is divided into this part. Okay, divided into this part. Second, it is divided into this part. Okay, okay, so now understand this thing very carefully. Okay, so what happened is the CLR divided this big heap memory into three parts. Suppose this thing is this thing is your generation 0, this thing is generation 1, and this thing is generation 2. Okay, So what happen is, if you can observe this thing very carefully, so you will find it that generation 1 is smaller than, generation 0 is smaller than generation 1, okay, and generation 1 is smaller than generation 2, which mean what, which means that generation 2 is the maximum memory capacity you have and generation 0 is the minimum capacity you have. Okay, so every time, when CLR divide your big heap memory in three parts, every time it is intentionally created those parts in such a way that the generation 0 will have the minimum memory and generation 2 will have the maximum memory and generation 1 will have the moderate memory. Okay, now the CLR will divide your your big heap memory into three parts like this. Okay, then what your what your garbage collector components will do is how it is managing your automatic memory allocation, right? So what happen is, when you start your program now, so what happen is, generally when you start your program, it will allocated multiple memories towards your variable, whichever variable you have declared inside your program, right? So all those variable need some memory, right, to store those values. So all those things, for all those things, it will allocated allocated those memories towards to the variable types as well as the object also. Okay, so same like variable, your program will create lots of objects also, right? Because you are working with C sharp, you are working with object oriented programming language, so object will be there, right? So for that only it will initiate a n numbers of object, okay, and n numbers of variables. So for all of this, your memory allocation management or your garbage collector, what it will do is it will create a list, okay, of all those things whichever getting aligned. Okay, it make a list, it will make a list and it will allocate a memory, okay, towards all of them. Okay, but it will just get this point, your CLR or your garbage collector allocate those memory from the generation 0. Okay, it will not allocate the memory from generation 1 or generation 2. Initially it will allocate the memory from generation 0 only. Okay, so what happen is, suppose some variable you have, so these are all the variables, okay, and these are all the objects. Okay, these are all the objects. Okay, so suppose two variable, for example, in the real life, there are n numbers of data types, variable and objects has been created. Okay, but for example here I have created two variables and two objects for example. And what happen is, when it will start your program, it will make a list of, okay, this fourth thing has allied, so I need to allocate some memory towards to that four things. Okay, so from where it will allocate the memory, from generation 0 it will allocate the memory. Okay, fine. After some time, what happen, the garbage collection will happen in the back end. And when the garbage collection will happen in the back end, what the CLR will do, the CLR will check the live status for this four thing. Okay, the live status of this four particular thing, first it will uh, get the live status. So it will make a list that, okay, this particular variable done with the job, so this particular variable status is dead now. Dead means it is not in a working status now, it will already did his work. Okay, so it will free up the space. Okay, then it will come to here, this is also dead, it is free up the space. It will come to here, this is also dead, free up the space. But when it will come to here, suppose it is find that this particular object, okay, is still running. Okay, this particular object is still running, it is not done his job yet. Okay, it will need some more time to done his job. Okay, so what happen is that time the garbage collector, okay, move this particular object, okay, move this particular object towards to the generation 1. Okay, towards to the generation 1. It is moved this particular object towards to the generation 1 and keep that particular object in generation 1. Means it is again moving this object and reallocating a memory in generation 1 heap memory. Okay, and parallelly it is free up the space from generation 0. So what happen is, now you have this long going object in generation 1 which is moved from generation 0, and parallelly after moving the previous objects and variable, after moving in generation 1, it will now search what are all the new variables which are coming in live state. So again those variable it will space allocate in generation 0. Okay, suppose some objects or some variables, new variables, it will allocate a memory again from generation 0. Then what will happen, then again when after a certain time, when again the garbage collection will happen automatically in the backend by CLR, no, what happen is again it will check, it will start checking from generation 1, that okay, now it will come to this object and it will check that whether it is done his work or not, what is the life status of this particular object. And if it will find, if it will find that okay, now this object is dead, it is completed, it is complete his work. Okay, what it will do is it will free up the space from generation 1, straightforward. But if the CLR or the garbage collector will find that okay, still this object is alive, it is not yet done by his job, okay, it will still take some more time. What it will do is again it will move this particular object from generation 1 to generation 2. Okay, and then it will free up the space from here, and then again it will go to generation 0, did the same thing. If suppose it will find this thing is dead, free up the space, this thing is dead, free up the space, this thing is not dead, okay, then shift this thing to generation 1 and free up the space. Okay, what happened? Free up the space, and again this thing also dead, free up the space, and again the newly lived variable or object, it will allocated in generation 1. Okay, so up to this point I hope you will all understand. Okay, so currently we allocated one of this object memory in generation 0. Okay, now it will shifted to, after that it will shifted to generation 1, and then after that it will shifted to generation 2. Got it? But what happen when again the garbage collection will happen in the backend? No? When again garbage collection will happen in the backend, it will come into the generation 2 and it will looking for this object life status. Okay, if it is find that okay, it is already done with this, with his job, okay, and currently it is on dead state, it will free up the space from generation 2. Okay, but if the CLR find that this particular object still alive, it is still not done with his job, it is still alive, that time what it will do, that time it will not move this object to anywhere else, it will keep this object in generation 2 only. Okay, if you think that time after that if it is still alive, then it will the CLR will move this particular object from generation 2 to generation 0, and then again generation 1, generation 2. So that thing will not happen. Once our object is reach inside a generation 2 heap memory, that time if it is still alive, then it will still remaining inside the generation 2 heap memory only. It will not gonna move to anywhere else. Why? Because the generation 2 only is the highest heap memory allocated to your program. Okay, that particular thing you have to understand. Okay, so means that's it. Okay, so this is the main mechanism which is going on when your garbage collection is happening in the back end. So like that your CLR will handle your garbage collection, okay, in the back end. So I hope you understood this thing. Okay, now we will come to the slide. So this is the heap generation. This is why we have created three different heap generations: generation 0, generation 1, and generation 2. Generation 0 is for newly allocated object. Generation 1 is object left after generation 0 garbage collection, and generation 2 is objects left after generation 1. So you got it now why I have written all those things, right? So that is the main purpose of why I have started with this slide, right? And then it have some phases. Okay, so phases is nothing but actually the work, all the work. When a new object got alive, then make a list, and then allocate a memory in generation 1, and then again when garbage collection happening, then again make a list, and all the dead objects, free up those spaces for the dead objects, and all the alive objects, move those alive objects towards to the bigger heap memory like generation 1 or generation 2. All those work actually divided into three phases. That is why a collector or garbage collection, in garbage collection we mainly see three phases. One is marking phase, where the garbage collector or the CLR will create the list of newly initialized variable or object. So those lists it will make, and then we will have a relocating phase. Relocating phase means again when garbage collection will happen, that time it will again update the list. Okay, they'll update the live status from the list, that okay, if all the things are alive now, what are all the live status. If that time it will update like few variables or objects as a dead status, or few variable and objects are still in live status. And then we will have a compacting phase. So in compacting phase only, all the if it will in the updated list, if it will find any object or variable as a dead, then it will free up the spaces from any of the heap generation memory. Or if it is find that any variable, or if any object will have still live status, then it will move that particular object or variable towards to the bigger heap memory. Okay, so these are all the three phases we are having. So simple and straightforward. It is straightforward it is. And after that, okay, benefits. We have some benefits in garbage collection. So garbage collection succeeds in allocating objects efficiently on the heap memory using the generation of garbage collection. Right. So already I have explained briefly these things. What is generation, heap memory, and how it is working. And the second point is manual freeing of memory is not needed, as garbage collection automatically releases the memory space after it is no longer required. Okay, and garbage collection handles memory allocation safely, so that no objects use the contents of another object mistakenly. Okay, and the constructors of newly created objects do not have to initialize all the data fields, as garbage collection clears the memory of objects that were previously released. Okay, so those are the benefits we have in garbage collection. Okay, interview question. So interview question, before discussing the interview question, I want to see you something. uh, so now we are in a visual studio, and as I have told you, right, we have a slide in very previous. uh, Here, if you can see, I have mentioned that if needed, a developer can handle a garbage collection from coding level as well. Okay, the GC class controls the garbage collector of all system. Okay, so here we will watch it in practical level. So I have a Visual Studio. I have opened it, and if you can see, I have used this namespace called system. So inside this namespace we will have a static class called gc. Okay, you can see that system.gc. Okay, you can see the description also, that controls the system garbage collector, a service that automatically reclaims unused memory. So if you go inside that particular class, uh, just yeah, okay. So here you can see it is a static class GC which belongs to the system namespace, and inside the GC class it will have multiple of methods, multiple methods like the collect methods and the collect methods. Okay, here basically method overloading or function overloading happened. Those we will learn in later session, but yeah, for now collect, and then get generation, and then get total memory, all those functions we have. If you want to see the definition, you can just click on this plus symbol. You can see a summary. Here the collect, for that collect method they given a summary called forces an immediate garbage collection of all generations. So if you use this particular collect method in anywhere in your program, so that time whenever this particular line of code executes, your compiler will do immediate garbage collection from all the generation of heap memory, generation 0, generation 1 and generation 2. And like that, it will have another, like here another example is get generation method. So what it will take is get generation method. The summary is returns the current generation number of the specified object. Okay, so if you are using any object, if you pass that object as a parameter inside this particular method, so that after that method will give you that in which generation of heap memory currently your object has been allocated. So all those things you can use it in your program. So here I have written just 3 lines of code, like I have called this gc.collect method, right? And then I have written a console message called the number of uh, garbage collection occurred in that particular generation is. Okay, so I have uh, I have used one more method called collection count. Here the description is returns, you can see, returns the number of times garbage collection has occurred for the specific generation of object. So I want to see that generation 0 heap memory, how much time the garbage collection has occurred. So I manually did a garbage collection first, then I want to see the number, that how many time it has occurred, the garbage collection. So if I run this particular program, so if you can see here, the number of garbage collection occurred in that particular generation is 1. Okay, and for example, if I commented out this line, but this particular line, so what happened is, if I commented out this particular line, that means the garbage collection will not happen anymore. So after that, when I will run this program, what the output it will give is, let's see, look. So now it will give the number of garbage collection occurred in the particular generation is 0. That means till now it didn't have any garbage collection in this particular generation, right? So like that you can use in your program in coding level also. Okay, and okay, now we'll discuss about some interview question. Okay, as per my experience, I have given multiple of interviews in multiple of MNCs and product based companies. In almost every interview, technical interview, the interviewer was asked me about either the CLR, and once I started explaining the CLR, the next question will be uh, from the garbage collection only. Okay, so in any interview, if the interviewer was if the interviewer will going towards the CLR topic, you just tell yourself, you just prepare for the garbage collection interview question also. That thing actually happening. Okay, that thing has happened with me in everywhere, so I'm telling you from my experience that thing. So the first question is, they might ask you that what is garbage collection, or what is the mechanism of garbage collection. You know, uh, as a developer, or can a developer manually handle a garbage collection? If yes, then how? And what is the use of gc.collect method? Okay, so there are multiple other questions also the interviewer can be asked, but the main thing is, if you understood my today's video, then I think you will able to give every answer whichever they ask to you from this particular topic, at what is garbage collection. Okay, so thank you very much for watching this video. I hope you will all like it, and you will all you have understood this particular topic, that what is a garbage collection and how it is working. If you have any confusion or any query, then please comment it below, and please if you have any feedback also, then also please comment it below. Okay, and please like my video and subscribe my channel, and thank you very much for watching this video. Thank you.